or does anybody know maybe one of them or want to guess? Yeah.
Nitrooxygen.
What?
Nitrooxygen.
Nitrogen?
Yeah,
Nitrogen, okay. What else? Oxygen?
Hydroxygen.
Huh?
Hydrogen.
Hydrogen? Okay, so nitrogen, oxygen, hydrogen. What else? What's the last one? Carbon dioxide. Close enough. Yes, out of those four, which one is the most popular or abundant in our atmosphere? Yeah. It's not carbon dioxide. Good guess. Hydrogen? It's not hydrogen.
Oxygen.
It's not oxygen. At least one more, guys.
Nitrogen.
There we go.
Yeah.
Process of elimination. I love it. Right. Nitrogen is the most prominent gas in our atmosphere. Does anybody know how cold I would need to make this room in order to turn all of the nitrogen gas into a liquid? In Fahrenheit, please. I'm not smart enough to do Celsius. Yeah.
What? Negative 17 degrees.
It is in the negatives. I'll give you that. Negative 1 degrees. Okay.
Negative 20.
Negative 20.
Wait, is it higher than negative 20?
Yes.
Okay,
Well,
negative.
yes.
Negative 31.
All right. I need you guys to take bigger leaps for me. All right.
Negative 602.
Okay. It is in the hundreds and it is in the negatives. Thank you.
Negative 999.
All right. Maybe not that too far. All right. You had a guess. Okay.
Negative 200. Negative 141.
All right. This could go on for a while. One more guess. Last guess. Yep.
Negative 196.
Okay. I would need to make this room negative 320 degrees Fahrenheit in order to turn all of the nitrogen gas into a liquid. For obvious reasons, I can't do that, right? But I do have a container of liquid nitrogen, which is exactly that. It's negative 320 degrees Fahrenheit. Give me a moment so I can pour some out. All right, so in my hand is a much smaller container of liquid nitrogen. Pour some out. All right, it is just about gone. Why is it gone? Who knows?
I can still see
Because
it.
it is no longer 320 degrees negative.
That is correct. Do you know why?
The room is not negative.
The room is not negative 320 degrees. You are correct. Roughly speaking, this room is about 70 degrees Fahrenheit, making it about 400 degrees Fahrenheit hotter than the liquid nitrogen. Question for you guys, what happens to air molecules when they get cold? Okay, good. Vaporize, okay.
They turn into water.
Okay. Anybody else? When air molecules get cold, they condense. They stick together. They shrink. This balloon is filled with air from earlier. And as I keep pouring liquid nitrogen over it, as you guys can see, it is shriveling up. All of the air is condensing inside of it. But if I take the liquid nitrogen away, unless it pops on me, as it heats back up and as it thaws out, it will return to its normal shape that it was before I started pouring nitrogen on the end of this, right? Just about there. All right, right on. It's back to normal more or less, right? Right. How much nitrogen is that? That's enough for now. What is this?
Ping pong.
Correct. What was a ping pong ball made out of?
Plastic.
Plastic. There we go. Plastic is an inflexible material. It can be brittle, but by inflexible, I mean it is rigid. It is not really designed to change its shape. It's not really designed to compress. It's not really designed to bend or anything like that. Anybody want to guess what will happen to the ping pong ball when I take it out of the liquid nitrogen and bounce it?
It will shrink.
Okay. Shrink.
It won't bounce. It will just like the balloon did, it will go in.
It'll shrink.
Stay the same thing. It won't break. Disappear.
Okay. Oh, yep, my friend up top.
It will shatter.
Okay, so we have shatter, shrink, won't bounce, stay the same. Wide variety of guesses here.
It disappears.
It'll disappear. Thank you for whoever said that. You have one more? Right, got it. All right, cool. So the ball hasn't shrunk. It has stayed the same. Good guesses, though. I see why you guys would guess that. Is... All right. Good job for whoever said stay the same. So why did it stay the same? Who knows?
Because it's plastic.
It is plastic, right? I said the answer earlier. It is plastic, meaning it is brittle. It is not supposed to bend. It is not supposed to change its shape. Also, the ping pong ball being a very light object probably helps. But yes, good job. What is this? Don't say it's an eyeball. I know it's an eyeball. What is this?
A bouncy ball.
It is a bouncy ball. What is a bouncy ball made out of?
Rubber.
Rubber. Right, exactly. Rubber. Rubber is the opposite of plastic. Rubber is what we would call an elastic material. Elasticity, not so much in the way that I can bend it or stretch it or whatever, but more that it is designed to compress, right? And it is designed to easily redistribute a force when placed upon it. For instance, what is this?
Ball.
Ball. Not foam. What kind of ball? Okay. What? Okay. Yes, it is a racquetball. Good job. A racquetball is also made out of rubber. Cool. When I say it's elastic, I mean the ball is able to compress, right? When you bounce a ball, it compresses very quickly and then springs back up to retain its normal shape, and it is able to redistribute a force very easily, right? So I'm able to bounce this, and it's able to come back up at me pretty quick. What do you guys think will happen to the bouncy ball after I take it out? Yep.
Right.
Okay.
It will stay the same.
Okay.
Melt.
Melt.
It will hard.
Okay.
It will do the same thing that the balloon did.
Okay.
It will shrink. It was like a piece will come out.
Okay. Break.
Melt.
Melt. Anybody else? Yep.
Wait.
Break. Okay, so we have break, be hard, shrink. Yes. Right. You think it will not bounce. All right. Got you. Cool. All right. So the ball has not changed its shape, although good guesses. I would probably guess that too. Guys, what are these vapors coming off? We never talked about that earlier. Yeah.
It's evaporized water.
Close. It's not water though. Yeah.
Smoke.
Okay, it's not smoke. What was I putting it in?
Nitrogen.
Nitrogen, right? So it is nitrogen gas returning to its gaseous form. We are now breathing it in a safe manner.
I knew it. Can I have it?
No. Why didn't it bounce? Yeah, buddy.
It's solid.
It is solid. Good, good. Yes, it is solid. Why? Well, I changed the physical state, that's why. But why didn't it break? Yes, it is frozen, making it a solid material, a brittle material, making it unable to compress and redistribute the force. I kind of wasted some nitrogen here, so let me just get some more before I do my last thing. Cool. All right. As we talked about earlier, this is a racquetball. It is made out of rubber. It is made out of rubber similar to the bouncy ball.
Wow.
I need you to stay for me. All right. But what is the difference between the rubber bouncy ball and the rubber racquetball? Yeah.
Because the bouncy ball has rubber inside it, and the other ball does not have rubber inside it.
Right. It's a hollow ball. Yes. What were you gonna say?
Maybe the rubber ball, the rubber ball will not bounce.
Okay. Hold on one second, my friend. I'll come back to you. Yes, like my friend up there said, the bouncy ball has rubber inside of it, right? It is a dense object. The racquetball is not. It is hollow. Yes.
It's going to do the same thing as the bouncy ball.
Okay, that leads me to my next question. What do you guys think will happen to the racquetball when I try to bounce it? Same thing as the bouncy ball? Yes.
It'll do the same thing as the
Same thing as the balloon, so shrink. Okay? Yes?
She's just saying hi.
Hi. All right. Yes. Break. Okay.
It would shatter.
Shatter. Break. Stay the same. It won't be hollow anymore. Why? I'm just curious. Okay. Okay.
I'm saying it's going to be hollow, it's just going to be full of nitrogen. Shrink. Change color.
Okay. Cool. All right. So we have shatter, break. Won't bounce. Will bounce. Stay the same. Shrink. Change color. All right. Right on. Ooh, I put that on my- all right, so it already sounds a lot harder, right, from hitting the walk. This is going to be one of those noise warnings that I talked about earlier. Don't touch it! Thank you. Cool. I will tell you when you can touch it. Now is not that time.
Can I have a piece?
Later on.
Yes!
All right, cool. So, why? What? Okay. Cool. You did guess it. I dig it. All right. So, why did it shatter?
Because it was frozen.
Okay, good. What else? Yeah. Because what? I'm sorry. Okay, okay. What else? Yes. Because it's hollow. Okay. When I froze the ball, I changed the physical state of the ball. I made it inelastic. I made it rigid. I made it unable to